Hello students, today I am discussing about the transport layer. Basically, transport layer is mainly responsible for congestion control and quality of service. The main focus of congestion and quality of service is data traffic. In congestion control, we try to avoid traffic congestion. In quality of service, we try to create an appropriate environment for the traffic. So before talking about congestion control and quality of service, we discuss the data traffic itself. Here we can see the traffic descriptor. Traffic descriptor are qualitative values that represents a data flow. This figure shows a traffic flow with some of these values. Average data rate. The average data rate is the number of bits sent during a period of time divided by the number of seconds in that period. We use the following equations like average data rate is equal to amount of data by time. The average data rate is a very useful characteristics of traffic because it indicates the average bandwidth needed by the traffic. Next we can see here the peak data rate. The peak data rate defines the maximum data rate of the traffic. It is the maximum value. The peak data rate is a very important measurement because it indicates the peak bandwidth that the network needs for traffic to pass through without changing its data flow. Then we can see the term maximum burst size. Although the peak data rate is a critical value for the network, it can usually be ignored if the duration of the peak value is very short. However, if the peak value data lasts 60 milliseconds, there may be a problem for the network. The maximum burst size normally refers to the maximum length of time that traffic is generated at the peak time. That means the effective bandwidth is the bandwidth that the network needs to allocate for the flow of traffic. The effective bandwidth is a function of three values: average data rate, peak data rate, and maximum burst size. The calculation of this value is very complex. Now, for the purpose, a data flow can have one of the following traffic profiles: constant bitrate, variable bitrate, and bursting. Constant bitrate, that means CBR, or a fixed rate, traffic model has a data rate that doesn't change. In this type of flow, the average data rate and the peak data rate are the same. The maximum burst size is not applicable. In the variable bitrate or VVR category, the rate of the data flow changes in time, with the changes smooth instead of sudden and sharp. In this type of flow, the average data rate and the peak data rate are different. The maximum burst size is usually a small value. In the bursty data category, the data rate changes suddenly in a very short time. It may jump from 0, for example, to 1 Mbps in a few microseconds and vice versa. It may also remain at this value for a while. The average bit rate and the peak bit rate are very different values in this type of flow. The maximum burst size is significant. This is the most difficult type of traffic for a network to handle because the profile is very unpredictable. To handle this type of traffic, the network normally needs to reshape it. Using reshaping techniques, as we'll see, bursty traffic is one of the main causes of congestion in a network. Now the topic is congestion. An important issue in a packet switch network is congestion. Congestion in a network may occur if the load on the network, that means the number of packets sent to the network, is greater than the capacity of the network or the number of packets the network can handle. Congestion control refers to the mechanism and techniques to control the congestion and keep the load below the capacity. Thank you, students.